Newton's laws of motion. It is very useful in examination point of view, whether it is CET or NEET. So, before going to discuss Newton's laws of motion, first of all, what is meant by force? Force is a pulling or push the body in which to produce an acceleration inside the body. That is simply force. Force is a pull or push the body which produces acceleration inside the body. That is nothing but force. And also, force is nothing but it is an external agent applied on a body to change the position of the body. There is nothing but force. Simple. It is an external agent applied on a body to change the position, to change its position of the body. So that is nothing but force. Suppose, so let us consider a body of mass m initially at A. Some force will be applied on a body. The body is moving from A to B. So some external agent applied on a body, position of the body changes from one region to another region. That is nothing, that external agent is nothing but what? Force. So F is equal to ma, that is Newton's second law. According to Newton's second law. What is the dimensional formula for force? What? M is equal to m, A is equal to L T power minus 2. Already we know. So it is a which quantity? Force is a vector quantity. Its direction and also magnitude. It is a physical quantity having magnitude and direction. So it is a vector. So now let us discuss Newton's first law or law of inertia. Newton's first law or law of inertia. So Newton's first law is nothing but every body in a state of rest or uniform motion along a straight line, unless it is compelled by an external unbalanced force. External unbalanced force. So that is nothing but Newton's first law. So once again, Newton's first law states that every body in a state of rest or uniform motion along a straight line, unless it is compelled by an external unbalanced force. See, for example, so let us consider a body of mass m initially at rest on the earth's surface. So there is no force applied on a body. The body remains rest. The body remains rest. Okay. So this is the first case. And second case is, suppose let us consider a body of mass m moving with a velocity v. There is no force applied on a body. The body continuously moving. In this case, please remember it. There is no air resistance or there is no viscous forces. So neglect the air resistance and the viscous forces. So let us consider body of mass m which is moving with a velocity v. There is no force applied on a body. The body will continually moving. Okay. So there is no force applied on a body. The body remains rest or the body moving along a straight line. That is nothing but Newton's first law or law of inertia. So the law of inertia is classified into three categories. That is inertia of rest, inertia of mass, inertia of direction. So what is the inertia of rest? So it is the inability of the body. It is the inability of the body to change by itself its state of rest. Its state of rest. So that is nothing but inertia of rest. Suppose, for example, the person inside the bus, the person inside the bus, of course, the bus moving suddenly in forward direction. The tendency of person falls in backward. While suppose the person sitting inside the bus, the lower part of the bus touches, the lower part of the person touches the bus. Okay. Then the bus moving in forward, suddenly the lower part moves forward direction, but the upper part remains rest due to inertia. Then the person falls in backward direction. So that is the example for inertia of rest. So it is the inability of the body to change by itself its state of rest. Its state of rest. So that is nothing but inertia of rest. Inertia of motion. So what is is meant by inertia of motion? Of course, same. It is the inability of the body to change by itself in a state of motion along a straight line. Along a straight line. So that is nothing but inertia of motion. So example for inertia of motion is, suppose the person inside the moving bus. So the bus moving with certain velocity, the person also moving with same velocity because of the person inside the bus. Okay, the bus come to rest suddenly. Immediately the lower part of the person come to rest. Why? Because of the lower part touches the bus. Bus come to rest, lower part immediately come to rest, but upper part moving with the velocity. Some velocity. So the tendency of the person falls in forward direction. So that is nothing but inertia of motion. Now the last one is inertia of direction. So what is the inertia of direction? Of course, it is the inability of the body to change by itself in its direction. So that is nothing but inertia of direction. Suppose a stone is tied with a string which is whirled in a circular manner like this. Whirling of stone, already we know. So during its circular motion, suppose the thread will be break out. If we suppose the thread will be break out, the stone will move in a tangential direction of motion. So that is the example for direction of that is inertia of direction. So these are the types of law of inertia. So there is inertia of rest, inertia of motion, inertia of direction. Now we will discuss the very most important one is, that is Newton's second law. Now next Newton's second law. So Newton's second law states that the rate of change of momentum is directly proportional to the applied force and takes place in the direction of force. That is nothing but Newton's second law. So Newton's second law states that the rate of change of momentum is directly proportional to the applied force. See, F proportional to dP by dt. So F is equal to some constant into dP by dt. Where in SI system K is equal to what? 1. Then the rate of change of momentum is equal to the applied force. So dP by dt is what? Change in momentum. Rate of change of momentum. Suppose, so dear students, let us consider a body of mass m moving with velocity u. Initially. So after that, some quantity of force will be applied on the body of mass m. So mass of the body does not change, but velocity of the body will be changes. The initial momentum of the body is what? mu. Final momentum of the body is what? mv. Then by the Newton's second law, so change in momentum delta p is equal to like this, p1 minus p2 or p2 minus p1. Delta p is equal to what? Like this, p2 is nothing but mv minus p1 is nothing but mu, that is equal to mv minus u. So this is the change in momentum. So by the statement of Newton's second law, the rate of change of momentum, I want rate of change of momentum, that is delta p by delta t is equal to what? M into v minus u by delta t. See, so like this, v minus u by delta t is nothing but what? That is change in velocity. Rate of change of velocity is nothing but acceleration, ma. So the rate of change of momentum is nothing but applied force. The rate of change of momentum is nothing but applied force. F is equal to ma. M into a. In this case, a will be the acceleration, m mass of the body. So the rate of change of momentum is directly proportional to the applied force and takes place in the direction of force. So dear students, the body moving, of course in this case the body moving along a straight line, the applied force is, the direction of applied force is along the direction of flow, the applied force is along the direction of momentum, then momentum will be increases or velocity will be increases. Or the applied force is opposite to the velocity of the body, opposite to the velocity of the body, momentum will be decreases. Opposite to the body, that is final velocity will be decreases, body will have deceleration, not acceleration. Okay. So, the body is moving like this, the body is moving like this, whenever some force will be applied along the direction of velocity of the body, while velocity of the body is increases, the body will have acceleration. Moreover, suppose the body is moving in this way, the applied force will be in this way. This is the applied force in opposite direction. In a opposite direction, then the body will have deceleration. Final velocity will be decreases. Moreover, the body will have deceleration. Finally, the body becomes a rest. Body becomes a rest. Okay, this is the Newton's second law. Simply, the rate of change of momentum is directly proportional to the applied force and it takes place in the direction of force. Okay. See, so F is equal to what? F is equal to m into A. So F is equal to m into A is nothing but dU by dt. So in this case, mass remains constant, dU by dt, velocity will be changes. Okay, in this case, mass of the body m is equal to what? Constant. M is equal to what? Constant. Okay, so now in case of variable mass system, in case of variable mass system, F is equal to V into dm by dt. dm by dt. In this case, V is constant, mass will be changes. Example for variable mass system, rocket, that is rocket. So the rocket is moving upwards, that is ejected gases in backward direction like this. Ejected gases in that is this is upward velocity, this is backward thrust. So the rocket moving with constant velocity, mass will be initial mass, of course. So suppose initial mass is 1000 grams, that is including the weight of the rocket and fuel. After some time, mass will be decreases because of fuel will left out continuously. It will be burned. Okay, so this is the variable mass system case. Force is equal to V into dm by dt. This is the rate of change of mass. Rate of change of, that is the mass will be decreases with respect to time. With respect to time. This is the variable mass system. Okay. Okay. So next one. Next one is change in momentum in different cases. 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 Suppose, first case, suppose a body is moving with velocity v like this. M be the mass of the body, moving with velocity v. So after some time, it collide with a wall. Collide with the wall. Then the body come to rest. The body come to rest. That is, so the body is finally dead. So final velocity will be 0. So in this case, change in momentum is what? Change in momentum is equal to final momentum like this, P2 minus P1. Delta P is equal to final momentum is what? 0 minus initial momentum is what? mv. Then, so the magnitude of change in momentum is mv. In this case, momentum will be mv. Next, suppose in this case, so this is the body of mass M moving with velocity v. After striking the wall, then it return back with same velocity. Return back with the same velocity like this. This is the mass. Same velocity. In this case, change in momentum is what? Change in momentum is equal to final minus initial momentum. So delta P is equal to mv like this minus mv, because of the final direction of velocity is opposite to the initial one. So minus mv minus of mv. So like this, delta P is equal to what? See, delta P is equal to what? Minus 2mv. Minus 2mv. The magnitude of momentum, change in momentum is equal to 2mv. 2mv. So this is the important case. Second one. Next one is, see, third one. Suppose in case of projectile motion like this, in case of projectile motion, suppose what is the change in momentum? Like this. This is the projectile. Like this, initial velocity u. This is the vertical component, and the horizontal component is what? U cos theta. Vertical component is what? V sin theta or u sin theta, whatever it. Into j cap, that is I cap. This is x axis, this is y axis. In case of projectile motion, what is the change in momentum? What is the change in momentum of a body at projected and that is maximum height. So the change in momentum of the body between change in momentum of the body between projection point and the final point. The final point means there is a maximum height point. So change in momentum of the body between projection point is what? Like this. And the final point like this. This is the final point. So change in initial momentum is like this. Initial momentum is, so u cos theta I cap plus u sin theta j cap. Because initially vertical and horizontal component both are there. And final momentum, so in this position, only horizontal component is there, but vertical component at final position at maximum height, like this, final velocity will be 0, then it will be 0. Then change in momentum is what? U cos theta I cap plus u sin theta j cap. And like this, change in momentum is what? Change in momentum is equal to Pf minus Pa. Pf is what? U cos theta I cap minus u cos theta I cap, like this. Of course, u sin theta. U sin theta into j cap. So both are cancelled out. Then change in momentum minus u sin theta j cap. So this is the change in momentum. Its magnitude always positive. Then magnitude is what? U sin theta j cap. So this is the change in momentum. So change in momentum of the body between projection point and the final point. And next one is change in momentum of the body. Change in momentum of a projectile, change in momentum of the body change in momentum of the body between projection point and striking point. Okay. So projection point and striking point, like this is the projection point and this is the striking point. So what is the change in momentum of the body between projection point and the striking point? So initial momentum is what in this case? Initial momentum is equal to, so like this same, u cos theta I cap plus u sin theta j cap. This is the initial momentum. So final momentum is what? So final momentum like this, horizontal component is there and also vertical component but is in reverse direction like this, minus u sin theta j cap. Then change in momentum is what? Final minus initial. Okay, final minus initial like this, u cos theta I cap minus u sin theta j cap minus u cos theta I cap minus u sin theta j cap. So in this case like this, cancel out, it is cancel out, ultimately minus 2u sin theta j cap. This is the change in momentum. So the magnitude is always positive, already we know, that is 2u sin theta like this j cap. This is the change in momentum of the body between projection point and striking point. Okay. So next one is suppose, see dear students, suppose this is a small metal plate. This is a metal plate. This is a metal plate. So of mass m. So this is a small gun. So a bullets are fired. So whenever a bullet is fired to the metal plate, the metal plate will be holding air. The metal plate will be resting air. So that means so number of bullets fired per second is controlled by the weight of the metal plate. Okay. So in this case, V be the velocity of the bullet and small m be the velocity mass of the bullet. So in this case, capital M be the mass of the metal plate, This momentum is mv. So the bullet is fired. One by one, number of bullets. Of course, this is the gun. The gun is fired by number of bullets per second. So the momentum, this momentum of the bullets controlled by total weight of the body. So in this case, how many bullets are fired per second? So in this case, what is the change in momentum? See dear students, the momentum of the bullet is equal to its weight of the metal plate. So number of bullets will be fired. Nmv is equal to what? Capital Mg. Okay. So now in this case, the bullets will be, after firing, the bullets are penetrated or immediately come to rest. Simply in this case, number of bullets are fired by gun is nothing but mg by mv. In this case, mg, m, total mass of the metal plate, and g is the gravity, m, mass of the bullet, and v, velocity of the bullet. So this is the one of the case. Moreover, in this case, suppose after firing, the bullets are returned back. With the velocity v. Returned back by the velocity. In this case, change in momentum is what? Change in momentum is initial momentum mv, final momentum is minus mv. So ultimately change in momentum is what? Minus mv like this, minus mv, that is 2mv, minus 2mv. I will take the magnitude of the momentum, so it will be taken as positive. So n in this case, like this, 2mv n is equal to mg. I want number of bullets fired per second, mg by 2mv, like this. This is the number of bullets fired from the gun. So then it controls the total momentum of the bullets controlled by the weight of the metal plate. Okay. Next another one. Suppose a body is moving with a velocity u like this or v. So it strike the like this. It strike the wall. Strike the wall, making some angle. So like this. This is the initial momentum of the body, final momentum of the body, like this. So this is the change in momentum direction, like this. This is theta, this is also theta. So the body is struck by the wall, then return back with an angle theta. Theta will be the angle between the initial direction of the body and the normal. Initial direction of the body to normal. So in this case, so what is the change in momentum? Change in momentum delta p is equal to 2mv cos theta. That is mv cos theta, initial direction, then final, and also mv cos theta. Total 2mv cos theta. So moreover, suppose in this case I will take, this is the theta. Suppose it is the theta. Theta is the, in your case, theta is the angle between initial direction and wall. Then that case, change in momentum is what? 2mv sin theta. This is also, two are very most important. So in examination point of view. Next one. So consider a small pipe of length L. So A be the area of cross section of the pipe. A be the area of cross section of the pipe. So a water is passing through the pipe and finally incident on the wall. Then after it will drop. It falls on the ground. So the water is emptied by the pipe with the velocity v. This is the wall. So final momentum will be 0. Initial momentum is what? mv. In this case, force is equal to what? Mass into acceleration. Of course, F is equal to m. Density is equal to mass by volume. Mass is equal to what? Density into volume is nothing but area into L. So rho A L. So V, there is nothing but T. Acceleration is nothing but velocity by time. So like this, force is equal to what? A, that is rho, density of the water, area of the pipe, L by T into V. So rho A, L by T is nothing but what? V. So V into V what? V square. This is the force. Force of the water falls on the wall. Suppose the water is back with same velocity. In this case, what is the force? In this case, the force will be double, 2F. F dash is equal to what? 2F. 2 into rho A V square. Rho, density of the water. A, area of cross section of the pipe. V, velocity of the water. Okay. So these applications are very most important. So next one is connected bodies. Are very most. Before that, one law of conservation of a linear momentum. Law of conservation of linear momentum. Already we know in regular classes, so we have already discussed law of conservation of linear momentum. So law of conservation of linear momentum states that the total momentum of the two bodies before collision is equal to total momentum of the two bodies after collision. See dear students, this is considered two bodies. So the masses are m1 and m2 moving with a velocity u1 and u2. This is the collision point. After collision like this, these are moving with v1 and v2. So masses are remains constant. Masses are remains constant. Then m1 u1 plus m2 u2 is equal to what? m1 v1 plus m2 v2. So then this is p1 and plus p2 is equal to like this p3 plus p4, p1 plus p2 plus minus p3 plus minus p4 is equal to what? 0. Total momentum is what? 0. So by the principle of law of conservation of momentum, total momentum of the system remains constant. Of course, initial momentum is equal to final momentum. This is nothing but law of conservation of momentum. So by using the principle of law of conservation of momentum, so find out the recoil velocity of the gun. So see, so suppose dear students, this is the gun of mass m. So bullets are fired with velocity v. With a velocity v, small v, and m be the velocity of the bullet. M be the velocity of the bullet. So whenever the gun will fire, so gun moves backward velocity and bullet moves forward velocity. So then by the principle of that is by the law of conservation of linear momentum, so initially like this, gun will remain stressed. After firing, so the gun moves backward direction with a momentum mv plus bullets moving fired in forward direction. The bullets moving in forward direction, that is mv. Then minus mv is equal to what? Small into mv. So recoil velocity of the gun is equal to what? So mv by capital M. This is the recoil velocity of the gun. So negative sign indicates the direction of gun is opposite to the direction of velocity of the bullet. Okay. So next one. Suppose this is a bomb. The bomb will be exploded. Then after it will break up into two parts. One part of mass m moving with a velocity v. Another part of mass capital M moving with velocity. Of course, so some piece will be like this, moving in this way. Remaining piece is what? M by v, m minus v. Okay. So moving with the velocity is what? Capital V. Suppose capital V. In this case, by the principle of law of conservation of momentum is same like this. M minus small m into capital V is equal to small m into v. So v, velocity of the big fragment, is equal to what? mv divided by m minus e. Okay, this is the velocity of the big fragment. Velocity of the big fragment. Okay. So next one is like this. Next one, connected bodies. These are the very most important students. Connected bodies. Suppose like this. This is a body connected with another body like this. The body of mass m1 and this is m2. This is the force will be applied on it. So the body is moving like this. So whenever some external force will be applied on this direction, the frictional force will be acting in opposite direction. So in this case, what is the net acceleration of the system? F is equal to what? m1 plus m2 into a. So a is equal to what? F net by m1 plus m2. m1 plus this is the acceleration of the system. Now This is the, dear student, please remember it, F is the force acting on M1. Okay, what force acting on M2? What quantity of force acting on M2? See, I will take free body diagram for M2. For M2, like this. This is M2. Of course, this is the tension or force acting on M2. Okay. So then tension is equal to what? M2 into A. Tension is equal to what? M2 into, what is the A? F net by M1 plus M2. M1 plus M2. This is the tension acting on M2. So on an example, I will take one example. So dear students, suppose so let us consider an example. Let us consider two bodies. There is 3 kg mass and also 2 kg mass placed on the earth surface like this. Some quantity of force will be applied, that is 10 Newton will be applied on the system of two bodies. Then the system is moving in this way. Frictional force will be acting in opposite direction. So what is the force acting on 2 kg mass? 2 kg mass. Okay. Solution. Before going to calculate the force on 2 kg massive body, first of all we calculate the force. That is what? Net acceleration. Acceleration is equal to what? A is equal to F divided by M1 plus M2. So total force divided by total mass. So what is total force? What? 10 divided by total is 5. That is 2 meter per second square is the acceleration of the system. Now, so find force on 2 kg mass. 2 kg mass. So draw the free body diagram for 2 kg mass. For 2 kg mass. So free body diagram like this, 2 kg like this. This is tension applied on 2 kg mass body like this. So then the tension is equal to what? M into A. So M is what? 2. A is what? 2. That is equal to 4 Newton. So 4 Newton force will be acting on 2 kg. What quantity of force acting on 3 kg? Remaining 10 Newton force will be applied entire system. So 4 Newton will be acting on 2 kg. That is 6 Newton force acting on 3 kg. Okay. This is tension. So like this, F net is equal to what? F minus T. That is 10 minus 4, that is equal to 6 Newton force acting on 3 kg. Acting on, this is a simple way how to find out the 2 kg mass, how to find out the force acting on 2 kg massive body. Very most important. First of all, we will draw the free body diagram. Okay. Suppose, let us consider 3 massive bodies. Let us consider 3 massive bodies or 4 massive bodies, whatever it, like this. So this is M1, this is M2, this is M3, this is M4. This is M1 students. Suppose F be the force applied. The system will be displaced by the application of force M. Okay. This is the tension T1, this is tension T2, this is tension T3. Which is more? T1 is greater than, T2 is greater than T3. So ఎందుకంటే T3 అనేది ఈ బాడీని మాత్రమే లాగుతుంది, T1 అనేది మొత్తాన్ని లాగుతుంది. So T1 tension is more than that of T2 and T2 tension is more than that of T3. Okay. So what is the value of T3? Before going to discuss to find out the T3 value, first of all we calculate the acceleration. So acceleration is equal to what? Total force divided by total mass. m1 plus, m2 plus, m3 plus, m4. Okay. So now acceleration, this is the acceleration of the system. Now find out T3. How to find out the value of T3? So T3, so this is T3 is equal to what? Free body diagram for T3. There is free body diagram for M4 massive body. See dear student, this is M4 like this is the T3. So T3 is equal to what? M4 into acceleration. M4 into acceleration is what? Like this. F divided by M1 plus M2 plus M3 plus M4. This is an acceleration. Okay, this is T3. Next, find out T2. T2 is equal to what? T2 అనేది నాన్న ఈ రెండిట్లో అవుతుంది కాబట్టి T2 is equal to generally M4 plus M3 into acceleration. Acceleration already we know. Like this, T2 is equal to M4 plus M3. Acceleration is what? F divided by M1 plus M2 plus M3 plus M4. This is an acceleration. Similarly, T1 also same. T1 is equal to what? M2 plus M3 plus M4 into A. So this is the way how to find out the different tensions between the connected bodies. Students, this is the very most important in examination point of view. Next one is that is Atwood mission. Atwood mission is the very most important, students. Atwood mission like this. This is the body of mass M1. This is the body of mass M2. This is a Atwood mission, like a pulley. Atwood mission. So in this case, the tension will be upwards like this, and M1 greater than M2. So acceleration will be in this case, acceleration will be upwards. In this case, acceleration will be downwards. Like this. It is more weight. Weight of the body always downward direction, M1G. Okay. So how to find out the acceleration of the system? Before, how to find out the acceleration of the system? Okay. See. So this is the tension upward direction. So in this case, dear students, please remember it. This is more weighted body, that is M1G minus T is equal to M into A, M1 into A. So M1G weight chasti undi kabatti weight lo tension minus chestunana, M1G minus T is equal to M1A. Okay, so this is an equation number 1. So from this, so tension is high, that is T minus M2G is equal to M2A. This is equation number 2. So adding 1 plus 2, adding equation 1 and 2. See, M1G minus T is equal to M1A, and minus M2G plus T is equal to what? M2A. Okay, cancel out. So in this case, G will be common. M1 minus M2, like this, M1 plus M2 into A. I want acceleration. Acceleration is equal to what? Acceleration is equal to M1 minus M2 into G divided by M1 plus M2. This is the acceleration of the system, students. This is the very most important. So next one is this is an acceleration. How to find out the tension? from equation 1 or 2, whatever it, from equation 1, from 1, m1g minus t is equal to m1 into a. What is the value of a? m1 minus m2 into g divided by m1 plus m2. m1 plus m2. Okay. So, this term of the tension at this m1g it is the minus minus m1g m1 minus m2 by m1 plus m2 that is equal to t. That is equal to t. So, m1g will be common 1 minus m1 minus m2 by m1 plus m2 that is equal to t. Okay. So, now m1g bracket begin m1 plus m2 minus m1 plus m2. Okay, divided by m1 plus m2. So, this is minus m1 and plus m1 get cancelled out. So, finally, tension is equal to what? Tension is equal to m1, m2, m2, 2m2, 2 m1, m2 by m1 plus m2. This is the tension in the thread. This is the very most important. Okay, students? Thank you. M2 into G. So, this is what? Acceleration. Common acceleration of the system. A is equal to m1 minus m2 into G divided by m1 plus m2. Okay? This is the acceleration of the system. Okay. So, moreover, suppose in case of three massive bodies, this is massive body m1, or I will take this is m, this is m, and this is m. This is tension T1, this is also T1, this is the tension T2. So, weight of the body always acts downward direction. Suppose in network mission it consisting of three massive bodies, each of mass m. Okay. So, this is tension upward, this is also tension upwards, acceleration downward direction in this case acceleration is upward. So, weight of the body always acts downward direction. That is W is equal to mg. So, in this case, see, in this case, acceleration is what? For downward, in this case, acceleration is equal to T. So, in this case, m1 is high, m1 minus m2. In this case, 2m minus m into G divided by m plus m. So, A is equal to 2m minus m, mg by 3m. Cancel out, that is g by 3. This is the common acceleration, of course. So, this is the common acceleration of the outward mission in this case. Three masses. In this case, A is equal to m1 minus m2 g by m1 plus m2. So అంటే ఏది ఇక్కడ m1 జాస్తి ఉంది కాబట్టి m1 సింపుల్ గా m1 minus m2 into g divided by m1 plus m2. సో ఇక్కడ ఏంట్రా ఈ రెండు మాసెస్ అంటే m plus m 2m minus m. ఈ రెండు జాస్తి కాబట్టి just like that 2m mass. So 2m minus m into g divided by same total mass m1 plus m2, but in this case 3m. m get cancelled. This is g by 3. So how to find out the T1? So in this case, tension is small compared to the weight. ఎందుకంటే ఇది పైకి వెళ్తుంది కాబట్టి టెన్షన్ జాస్తి ఉంది. Tension T1 minus weight mg is equal to ma. M into a. So T1 is equal to what? Ma m asadu mg plus ma. So T1 is equal to what? Mg plus m into a value g by 3. So that is 3mg plus mg, 4mg by 3. This is the tension T1 in this case. Simple method. So T2 is what? T2 is what? I will take a free body diagram. Free body diagram for mass m. So I will take a free body diagram. This is mass, this is the tension T2, this is the weight W is equal to mg. Okay. So now in this case weight is high. So mg minus T2 is equal to ma. Okay. mg minus ma is equal to T2. Okay. ma is side minus T2 a side, that is T2. ma mg minus m a, what is the value of a? G by 3. 3mg minus mg, 2mg by 3, that is equal to T2. This is the tension T2. This is the tension T2 already find out. T1 also find out like this. T1 or T1 both are same. 4mg by 3. And last one, acceleration also calculated. Atwood mission, important case. Very easy. Atwood mission.